So no worries actually. All right. So if they have a question, then I can answer that. Okay. So tomorrow, even you are not available. Uh, uh, uh. Okay. Okay. So okay, let's see what we can do. Probably in case. So if you're traveling for 3 weeks, in case you're traveling for 3 weeks, then okay. So when you are okay, okay. So next week you will be available. All right, all right. I'll see. In case nobody else is joining, then today, then I'll keep a holiday for tomorrow, and then we will see you next week. Okay. Now let's start with today's session. Today's session is interesting. Today's session is interesting, and so we'll discuss something called scoop first. As So in the beginning of the session, we talked about the import data import export tool. If you remember in the diagram just below the HDFS, we had put Flume and Scoop for data input output. So Scoop is an interesting tool. Scoop is for importing data from unorganized files, sorry, organized database, which is relational database, to our HDFS or Hive. So this is a classic import export tool. It has interesting way of importing data. Okay, so it even uses MapReduce to import the data to HDFS. So we'll talk about that part quickly. And here, so Scoop, like with every other tool, it's an open source tool. It is for extracting data from a structured data source such as MySQL, MS SQL, or any database which supports the JDBC standard. All right. That is nice thing because JDBC is probably supported by almost all the databases, which effectively means this scoop can connect to any database and put the data into HDFS or HDFS in or HBase. All right. Now, and also from HBase or from file system, it can put the data back into your database. So it is data in and data out for both the things. Okay, we'll go through a hands-on exercise in which I'll demonstrate how to do the data back and forth both the sides. Okay, and in case you want to create your own connector and existing ones are not fitting to you, you can write your own connector, right? And that's the extension framework. And these connectors are also available in Java, JDBC compliant, which means everything is you can pull in data from every place, right? So if you go to the command line, you will see something called scoop. Let me just check on what all machines do we have clients available. So scoop is on all 4 machines. This is Ambari, which we are seeing right now. So Scoop is available on all the machines. All right. So I'll just pick a call and I'll let you know. Just give me a second. Right now we have, so it shows you that the Scoop client is available on all the machines, and we are on here. And also let's just see Hadoop 2 as a student, Hadoop 2 dot nobigdata.com. So here, okay, okay, good. And yeah, let's see if Scoop is working. Scoop help. All right. Yeah, it's working. So the important part is that once it can generate the basically the bindings. If you remember, we used to have those entity frameworks where we used to define classes for data description, and i- and then we run our entity framework to load the entities and dump the data. It's the same model. So first, when we say code generation, it generates those entities using which you can import export the data, so that you don't have to keep defining it all the time. All right. So that is a part called code generation, and we'll talk about it a bit more. So so Scoop is modular, and you can define your components and use the extension framework and to enable Scoop imports and exports for the data store. In very simple words, using this methodology called connector, you can uh, just like JDBC connector drivers and all, similar in the similar fashion, it also provides you connector mechanism. In the future, there is a new database. People can write a connector for that database, and then you're done, right? And probably any database which comes up, they always come up with their JDBC driver. So let's just see, where is our MySQL running. MySQL is required for Hive, HBase, Yarn. All right. So let's say that. So basically, for the demonstration of input output, what we are going to do here in this session is, first we'll create a table in MS SQL, and then we will import that data onto using Scoop into our HDFS as well as Hive. We'll do both the things. Okay. So just a second. So, and we say, okay, so I will have to log in as a root, and probably MySQL would be running. Yeah, MySQL is running. And you can see show databases, and you have this database is scoop2. So MySQL is already running, so we don't have to run MySQL. And show tables. We already have these two tables from the previous session. And let's just drop tables sales. Okay, show tables, drop table widgets, show tables. Good. So we have deleted the tables. Now here what we're trying to do is, in the MS SQL, we are trying to, sorry, in MySQL, not MS SQL, we are trying to create these widgets, right? And right, so we can see describe widgets. So we have created this table with the ID and widget name as one column and price as decimal, and design date as date, version as int, and design comment as varchar. Perfect. So this is our widgets table which we have created, and let's insert some dummy data to demonstrate our point. All right, so we can say select star from widgets, and you can see that we have inserted some data. Now our objective from now on is to import this data into our HDFS. Okay, so let's say it's pretty simple actually. So all we do is here we say scoop import and connect to my localhost database. Here this is my URL and this is my database name. And here I'm telling that uh, okay, okay, this is my table in which we have put a widgets. All right, and minus m is there are only one number of reducers. Okay, sorry, not this way. We have to get out of the command prompt and now here. So it says that no column to generate the class writer. All right. Access denied for the user. Okay, okay. So what do we do in such scenario? So we say, okay, so why does it, the driver does not have any, okay, okay. But if we understand correctly, did we give permissions on these tables? So we have actually set this. And select star from widgets. Hold on. I think we just need to tell this guy. Okay, how do you provide login and password in JDBC JDBC URL? So basically, this is how you pass MySQL colon. For MySQL, we are looking forward MySQL, and here we go. So it says that host blah 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 and port number. Here you have port number, host name, this host name, username. Okay, let's just have a look. So this is my JDBC one where slash db is there. Why is it that way? No, I think there is something. Anyway, for time being, let me just demonstrate to you with the root account. All right, let me just demonstrate to you for time being. So basically, on Hadoop 2, I have started a server. Now, when I say MySQL, it shows me show databases. and then I say scoop ex2, so tables, select star from widgets, right? Now here I go. All right. So basically I'm importing this file. Access denied for this user. Why would it be access denied? Any idea? Grant all privileges. So here you go. Now let's see if it allows us. I think this is all right. Do you get it? No. So it says access denied, executing the statement this access denied for this user at localhost for this database, right? And we have explicitly said that allow the local host, right? And this is something we need to look into. So there we are. Let's just see, how do you define URL, username, MySQL, JDBC, driver, password, user, password, passing my, okay. So guide to JDBC URL, and so here it says that bin ID. Okay. Okay, actually there is no way to do that. Are you also getting the same error? Are you trying to do the same thing? Yeah. So JD, problem is that I need to pass the login. Okay, okay. The problem, I got it. The problem is I need to give it the correct name, right? So what I need to do is I need to tell it to grant all the permissions here. Grant all the permissions to Hadoop 2 and Hadoop 2. Let's see if that works out. And so, all right, now we'll try again. What does it say now? Access denied for the user. Actually, the username is not being passed. If you see, username is not being passed. That is the only problem. Yeah. So I'm just wondering, where do you keep? I forgot completely. Where do we need to you to use to put? Do we need to put like this? So when I do this, it says error executing this. The driver has not received any packet. The driver has not received any packet. Mhm. So it says that access denied for this user to this database. Okay. Now let's just try one more thing. We give uh, uh, Hadoop to nobigdata.com, and we also say nobigdata.com. Right now, let's see. It still says that Hadoop 2.nobigdata to the database Hadoop access denied for Hadoop 2.nobigdata.com, which is right? Here am I missing something? Can you help me? All right, don't worry. Acha, no, you can't do that way. Mm-hmm, mm-hmm. How do you define the username and password? Like this? Let me just see if Scoop provides a way to do it. So here it is. So here you have to provide connect, which is fine, which is what we have given, and the driver name is there. Host colon port question mark the database property equals value. So you mean to say that if we put this way, it will work? Let's just see. Mhm. It says unknown database Hadoop ex2. I got the problem. It's not Hadoop ex2. That is the mistake we have been doing. So it's actually this. Huh. Actually, it's not a problem of the connection URL. Just see, it's because of it's because of the wrong database name which we have been putting, and it's funny actually. Okay, so it says encountered this exception. The widget table is already there at this location because of the last thing which we were running. All right. And so what we'll do is we'll just remove that file, Hadoop fsrm, and So if it's a directory, let's have a look at it first and then we'll delete. We can put -r. Yep. So I'll tell you. So by default, it will be in your home directory. Okay. By default, it will be in your home directory, which is user slash root slash in that one. But you can define your directory using a command line option. All right. So it is deleted. All right. So again, we go ahead and run it. So now what all we have done so far is only created a database locally, created a table, put some data, inserted some data into that table in MySQL, which we have done so far. And now we are moving this data from this location to our HDFS. All right. And you should notice that it is actually doing MapReduce even for this. Okay. So let's have a look at it. The driver has no, again, what exactly is the problem with this guy? It says communication failure. Okay, basically it tried to communicate and then it failed. But one reducer failed, so it has shifted the job to some other location. Let's have a look. So it has created this output folder inside widgets, which contain your data, just like any other MapReduce job. All right, so you can see that this data has come as comma separated values in that file system. All right, so it has come as a file system over there. All right, now we have got these records already available in HDFS. Make sense to you? So we were successfully able to import this data, and also during this it created a Java class here which basically which is basically a representation for ORM1. You see the ORM class for the table called widgets, right? So Scoop doesn't help you in that way. Scoop doesn't help you in that way. So ideal way of doing that is you combine your data already in the same database and then you import the data. Or you import all the tables from both the locations to the HDFS, and then you can do that. But probably you can put a filter. Okay. So if you see scoop help, and so here you can see that in importing scope help import, right? So importing, you have got so many parameters. Let's just go slowly one by one. So connection manager is fine, and okay, there is also some way to set the password. All right, all right, and username is also there. Okay, query. Yeah. So basically, but this you can do in case you want to just, in case you just want to import a certain section of the data from a particular table, you can provide a query statement. Okay, and that data will be imported over there. Make sense to you? And also here the warehouse directory you can define. And now this was simple import from Hadoop, from the MySQL to our SQL database, MySQL to HDFS. All right. And this file is created, which you can use as a ORM. Okay, which you can use as ORM, and you can basically load the data back and forth. Right. So basically, if you see here, if you see this widget dot Java is created. Okay, this is automatically generated, and it has all those fields. If you see get price, uh, okay, if you see set price, get price is there. So it represents each row in this table, which you can further use when you are programming. Okay, so that you basically, this whole ORM thing is generated for your convenience. Okay, this is basically a layer. So whenever there is a data import export happen in any kind of in any kind of import export system, so always you define a middle format, which is somewhere like an ORM format, and the input to which is from one format, from one driver, and output to which to another driver. So the property of this ORM file, why it is generated, because from this, so whenever you are writing a connector, you only have to write your connector with respect to the ORM file. Okay. So basically, if you are reading from MySQL, so you need to know what is MySQL and what does ORM provide. Okay. So, okay, let me make it further simple. Say you are supposed to write a connector for a new database which you just invented. Let's say Pranav database. Now, for Pranav database, what we need to do is we need to import the data from Pranav DB. From importing, while writing this connector, all we have to do is we need to read from from Pranav DB and create these objects, ORM objects, and that's it. And rest of the things will be taken care by Scoop. Similarly, to export, now you don't need to write the logic of converting PrintfDB into HDFS or any other format. All you need to write is a connectivity. How would you prepare these ORM objects? How would you prepare this object using PrintfDB? All right. So that is the biggest role of this file. Now, now you can also utilize this file as an ORM in your Java code. Okay, because this file knows properly, it represents your data. It represents each of your rows. Was I able to explain, Pranav? No, it doesn't have data. It doesn't have data. It is only a representation of each row of your table. And it has the definition like what is my output delimiter, and it has okay, it doesn't have data. I don't think it has data. So let me just see. Select select star from select star from okay, use scoop ex2 and select star from widgets. And if you, let's just try to look for gizmo in widget.class. See, it's not there. Okay, similarly, let's just say flagship. Let's just say flagship. It's not there. All right. So basically, it's a what do you call boilerplate code for uh, converting your data format into a format which Scoop will understand and will convert it into further into HDFS or maybe Hive or whatever. Great, great, perfect. So here we gave a demonstration on how to export the data, import the data from MySQL to HDFS. Now let's take another example where we'll create a table and we will also create a Hive table. You remember if we used to create a Hive table and then import a file from HDFS? In so instead of going to those steps, now, if you have to load this file which we just imported into HDFS, again you have to do create table blah 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 and then load this HDFS file into Hive table, right? So instead of going to going one step that side, Scoop can help you directly translating a MySQL file into Hive table, okay? Into a Hive table. Now, if you see, so first you will do is first you will create a MySQL table using this one. Okay. First you will create not MySQL. You already have MySQL table. First you will create uh, basically a table in Hive as well as move the data from this location to widgets table, widgets file in the Hive. Now in HDFS. So just now what we have done, we have taken widgets table from MySQL to HDFS, right? Now, next step is if you have to move this data onto Hive, what you can do is you can create a Hive table like this. So it will just create a Hive table for you. Close, close, yeah. So this is creating a Hive table from the same connection and then it will creating this, okay? It simply will create a Hive table, right? Now the next step is that we load that data into into if you go into Hive and then say load data from this file to my tables. Okay, basically you will have to move. What was the table which we were doing earlier? This one, right? Part M0, right? So we can say this. So it says unable to move source HDFS user widgets this to destination warehouse this wait into table. Okay, just a second. Hadoop fs minus ls. Now we have got a directory called widgets. Right. Okay, now we need to do load my data in this path into this table, and let's just say Hive, and let's see if the widget table was created. Show tables. Right, so we have got widgets table here, and we can say describe widgets. We are inside Hive right now, and we'll say describe formatted. So describe formatted shows that this is where the file will be actually created. All we need to do is move our data from this location, and we say part. What does it say? Destination. Mhm. Okay. Why is it doing that? It's saying app Hive, there is a location already created, and load data in this path into a table called widgets, which is correct. Unable to move HDFS file source to the destination, success underscore copy. Alright, so let me just have a look at what's going on with ls apps hive warehouse and widgets. Or what I think what we should do is actually drop this table which we had already created last time and do it from the beginning. That will be clear. And also because that table already exists. If you say select star from widgets, which it already exists. It already has the data. See? So drop table widgets. Now let's just do this. Now let's create Hive table again from the database. So the main reason was the table was existing already. And now if you see Hive, if we go, now let's just see. So right now the table exists there. If we say table describe our widgets table, it'll show you the table structure, right? But if you say select star from widgets, it doesn't have anything right now. So we are in Hive right now. Now the next step is to load the data, right? So you can see that there is a there. Okay. So it is successfully imported now. Perfect. So basically this only did was this step only did was, so these are all three steps combined. So first what we did was we imported the data from our table into the HDFS, right? As in HDFS, you will see the each table is imported as a folder under which there are various parts. More the number of reducers you keep, if you have m minus 2, there will be multiple parts created in this folder, right? Now the next step is to create a Hive table, which is basically the metadata, which we used to define. Remember when we were talking about Hive? The next step is to load this data into a Hive table, right? Now, there were three steps in that. To avoid all these three steps, you can simply do this. You can, let's say, drop widgets, right? Drop table widgets. Done. Now let's also delete Hadoop -fs -ls widgets, right? 1 second. So okay. So widget folder is already existing, and let's just delete that folder also, right? So now that folder has been deleted. Now, if you have to do all these steps in a single shot, you can do this. Now it imported data into HDFS, as well as it is going to load the data to our Hive table. It is going to first copy the data from MySQL as comma separated into HDFS. Second, it is going to create the metadata in Hive, and afterwards it is going to load that HDFS file directly into your Hive table. Now let me have a look at your question. Let it throw error, that's all right. Right? Now why does it say that earlier also? Basically it is probably trying to connect MySQL from other machines, and that is what is bothering it. And maybe people are not able to connect to this MySQL from other machines. Okay, that's not an issue, let it do. Alright, now it has done something. Let's just have a look if it has done something. Now, if we go into Hive, has it created a table? So what have I done? Connect to MySQL, create a table, then does the Hives import. And show tables, and select star from widgets. See? It has done all the things in single shot. If you remember, we deleted this table before earlier, and now it has done all the things in a single shot. So this is the way you can import the data from Scoop from using Scoop from MySQL or any other database, and that's all, right? So this is in a single step. Those all three steps done in a single shot, and here it does not create an HDFS file. It whatever it created, created temporarily probably. Now okay. Now Now, similarly, we can do other things. If you have a big file loaded in Hive, or in HDFS, you can move that data into the into your SQL database. All right. Now, there could be multiple circumstances. There could be multiple situations. There could be multiple MySQL servers. MySQL servers in multiple processes running on multiple machines of MySQL, from which Scoop might be pushing the data into HDFS. And that is generally the case. So generally, whenever what people do with the HDFS is that whatever data they have to truncate, before truncating the data, they move most of the data to our our HDFS. Or the other practice which I see in the industry is whatever data is coming in fresh, they keep a copy into HDFS continuously or into HBase, right? And this is how you can just, in the similar way, you can do import into your HBase table, right? Let me just see if there are single quote problem. Yes, I found one problem. That single quote is always troublesome. So here I'm doing the same thing, but this time I'm trying to import the data into HBase. It's doing something. It's trying to connect to resource manager. There are number of splits equals 3. Why the 3? I don't know. And let's see what goes on. It should create a table called my HBase table. Let's see what happens. How many error does it give? So basically this happens when multiple nodes try to communicate with MySQL. Probably we'll have to change the setting somewhere so that it starts accepting the connections from outside. This MySQL is local and I have denied the access to our MySQL from outside. So why keep copy in HDFS? So what I was trying to explain is that in industry, we generally try to keep the data inside Hadoop as a backup copy. So and also make this data available to researchers so that they can create a lot of insights onto the data. And in MySQL, in we keep since in your traditional RDBMS, you keep on either moving data out into file system or you keep on deleting purging the data if there is older data like 5 years ago data. So we call in industry most of the older data like few 10 years ago we generally purge. So instead of purging the nowadays people follow a practice to keep a copy of the whole data in HDFS because in HDFS the data HDFS is far more reliable. You can have multiple replica on and you can have a multiple computers and the devices are cheap. So SDFS makes a great solution for for batch processing, and therefore it is okay to keep the whole data into Hadoop. So it is doing something. I don't know if it will. No, it did not. I think we need to create multiple jobs. Basically, we need to see if we can make this MySQL fix MySQL. Could not find HBase table. Could not find my HBase table. Either rerun it with minus minus HBase create table. Ah, we have done HBase minus minus create HBase table. Mm-hmm, mm-hmm. So basically we'll have to change this. Okay, all right. Import this data into. So let's say what has gone with HBase shell. And we say list only my table is there. There are no other table available. Create HBase table. Why? HBase create table actually not. Let's just try with this one if that works. Otherwise, we'll see if we can make our MySQL public. Looks like, what is it saying? This Java path is irritating. It's really unnecessary. Okay. This look like you're importing from MySQL. This transfer can be faster. Use minus minus direct and options to exercise MySQL specific fast path. Okay, we can try that too. We can try that too. No, I think that it's a socket problem, which is we need to have a look at it because this guy is trying to connect, which means your mapper, your task, which is mapper, is trying. If you see, scoop map reduce DB and DB input format, which means it is trying to connect to MySQL, your mapper, to load the data. If you see, the map reduce task was run and reflection utilities have set the config, then it is trying to set the input. If we want to purge a data file to refresh data, do we first delete it from HDFS and then import it again? Yes, yes. But the general practice is that in case you have too much of data, you will like to avoid purging the data because it is because transferring data might take days. Okay. Therefore, the time lost in transfer is equally important as your data, right? So the general practice is call a function called append to a file. If you have got some more record, we can append to a particular file in HDFS. Is it always one file for each table in RDBMS? Yeah. So in this case, if you remember, we discussed about Hive. It is basically one folder for a table. It's not a one file for a table. It's always a folder for a table, right? If the file is splitted, then how do you append? So file is splitted, you mean by HDFS? Yeah, so you don't have to worry about internal splits. Okay, when you say append to the file, it is the duty of HDFS to do that on your behalf. It will find out where does it need to append it. Okay, so if you say Hadoop Hadoop minus fs and then help, then it will show you the details on how to append to a file, right? Driver has not. Okay, maybe this MySQL need to be reconfigured properly so that it can start receiving, let's say direct. We should try direct. So there is something called a direct when we talk about, and you can also define like what column family you need to import this data into. I'm just wondering there should be a way to actually where clause. Okay, you can also specify a where clause so that only the portion of that file is picked up. And there would be a way to even define the columns you need to pick up. You can define here what columns do you need to pick up. Here there is a direct way of importing. Mhm. So probably we will have to put it over here. Mhm. At minimum, you must specify connect and a table, which is alright. We have already defined our table at base. Never mind. I think this MySQL need to be reconfigured. Try doing it again. We'll doing it again later point of time when we have configured MySQL. So because if you say if you go to this machine and say telnet hadoop 2.my no big data, I'm on Hadoop 1 right now, no big data.com, and then we say 3306. Okay, see, it says host is not allowed to connect to MySQL server closed by foreign host. Okay, I just hope. No, it is not letting it pass through. Retrieve three records. Finally, because that particular mapper, if it has run on the local machine, then it was successful. Okay, let's say, so we're just lucky this time. We're just lucky this time that mapper was running on local host and therefore it was able to connect to MySQL. Ideally, you should make sure that MySQL is accessible to your cluster should be able to access MySQL so that for import to happen successfully. What's going on? What is going on? Okay, let's see if it has come something. Yeah, you can see that my HBase table has come. Okay, scan my HBase table. Scan my HBase table. Now you can see. So value is connect to two gizmos. And that is my first column. Column name, column family is design comment. Sorry, column family is CF1. All of these have gone into the same one, right? And there are three rows, 1, 2, and 3. This is 1, and this is 2, right? Does it make sense to you? Good, good. Yeah, all in the same column family. But if you want a different column family, you can also specify that in the query. Here there's a way to here there's a way to specify column family here like this, and that's all. Great. Now let's move on. All right. So we were able to successfully import into HBase as well as Hive as well as HDFS. All right. So basically here our only problem is that our MySQL was not accessible from our mapper. So under the hood, this is creating mappers. This scoop is creating mappers which will hit your databases directly from each data node and try to get it, each task node, and try to retrieve the data and load it into the file. And that actually helps in terms of the distribution, in terms of distributed loading your file. and this will make it very blazingly fast. If there are multiple connections parallelly pulling the data, that will be faster because you are utilizing multiple machines bandwidth. Okay, and also multiple machines, though your this MySQL database will be the bottleneck, but other things will not be the bottleneck. All right, great, great. So there is another way of doing it. Say you have got a file called sales.log. Let's just see if we have already created Hadoop fs minus ls. Oh, not this way. We will. Should we go as a student? I think we should go as a student. All right. Now let's have a look at, not this way, Hadoop Hadoop fs minus ls. Do we have sales log over there? Do we have sales log? Okay, let me just see if we have kept inside data. No. And do we have under asgiri? There is one file. Okay. So under say here, can see if you see. So we have got this nice file which has our this content. You see, this is a comma separated content, exactly this one. And now what you're trying to do is you want to import it into Hive. Okay, you want to import it into Hive, and as a next step, you would like to import a Hive table into. All right, so we are trying to create a table called sales. Let's see if it already exists. Great. So we have already imported. In case you want to drop this, drop table sales. Just drop the table. Again, we are creating. Did we? Great. So we have got select star star from sales. Nothing at all. Select star from. Okay, great. Now there is nothing in the sales. Now we load our file which we just created. So we have this sales.log. We created Hive table. We are loading this file into our Hive table, right? Perfect. Now we have got some data. Not this, not this. We have got some data in our sales table. Perfect, perfect. Now, what we can do is, now we have done with importing data into Hive. Now, next step is we go to our MySQL. All we are trying to do is we are importing show table, use scoop ex2 and show tables, and there is no table left. Perfect. Now, what is the state of sales? Nothing else at all. Now, we had created a Hive table. Now we are moving that table from Hive, basically copying the table from Hive to our, not this way, yeah, to our MySQL. All right. I just hope that it doesn't create multiple mappers. Input paths are these, number of splits are these, and how many maps it is creating. Preparing to use a MySQL stream result set. So as we described earlier, you can define your own result set in MapReduce. It has created MySQL kind of result set, and then it's executing that one. So this one is successful. Excellent. So if we say MySQL and say select star from sales, sorry, use scoop ex2, and then say select star from sales. What? Select star from sales. Oh, not from sales. It has to be from sales. Sorry for the typo. There you go. So we are successfully able to import data back and forth between Hive and MySQL, but we have not demonstrated the aspect of importing data from HBase into your MySQL. That is something you can try exactly in the similar fashion. All right, that you can try it out. Okay, so we are done with this part. Now the next point which we want to discuss is the Flume. So today I think we have enough of time, so nothing to worry on this time aspect. All right, do you want to take a break now? And let's meet at 10 p.m. and take it forward. Okay, great. Let's break for 10 minutes. 10 minutes. Meet at 10 o'clock. Hello. Cool. So we done with the scoop part. So basically using scoop, you can import, export from any database into HDFS or Hive, back and forth both the sides. And that is the power of scoop. There are a lot of command line arguments for each for HBase, Hive, as well as HDFS. And you can utilize those command line arguments, such as you can put a filter, you can put a where clause, you can specify which column family to import into, and so on and so forth. Okay. All right. So in a lot of environments where there is a lot of collection happening into unorganized data, specifically the plain text one, there we need a mechanism to import this data into HDFS. All right. So basically, it is moving the logs from all sorts of servers onto our HDFS. That is the whole idea. So, so basically, unlike saying that this is an import export tool for unstructured data, it is actually a way of copying lot of data from a distributed services. What does it mean by distributed? Say you have got 50 servers running the website, and those servers are each logging the errors, syslog, as well as those servers are having Apache servers, which is logging the events. Now, what do you want to do is, okay, right? So, what do you want to do is that basically there is a lot of data coming back and forth, right? On your web servers, what you want to do is copy the data from syslog onto a central service, right? Now there are two ways. First is you keep on putting it into file system, and other is you right away capture it from syslog service, or you build your services such that all of those services start logging into directly Flume, and Flume pushes the data onto HDFS. Okay, so Apache Log or any of these systems are the best candidate for keeping all of their data onto HDFS, right? And therefore, basically meaning to say that any logs, right? Because logs are huge in nature. Logs are not, it does not need to be transactional in nature. So they are the best candidate to be pushed to HDFS. And most of the people, they start using HDFS just with the logs as their first data set, right? Now, for Flume, the main role is to be able to construct a network of such nodes which keep on pushing the data to HDFS. Okay, so it's important is efficiently collecting and aggregating and moving large data, and generally it is log data, plain text data, to a centralized store. All right. Now the structure of a log is okay, and the Flume is basically supports wide variety of sources. So each log has, okay, I'll just describe it this way. So Flume consists of these four elements. One is client. This is our client, which is web server. Then web server sends the data to something called a source. Source is something like syslog or log4j, and that source puts the data into a channel, and the channel is basically has a very interesting properties to carry the data to the sink. Sink is something like HDFS copier, which absorbs the data and puts into HDFS, right? Now, if you have multiple kinds of sinks channels available or source and sink available, then you can build a very concrete, very interesting kind of complex systems, such as if you just repeat another channel over here, and there is a way to siphon the data from one channel to another, you can have multiple routes to HDFS, right? So you can build this network. So one web server pushing the data into this channel and then coming to this sink, and then this. There could be another sink over here bringing the data from elsewhere, and so on, right? And this is very interesting. This is very interesting because you can build really complex systems using this. Okay. Now, these are the four terminologies you need to remember. One is sink, channel, source, agent, and client. Here we have not written it specifically, but it is called client. Okay. So these are the five terminologies. This whole dabba, this whole box is called agent. This, the actual producer of the content is called web server, and the source is something a kind of a adapter which takes the data from web server and puts it into channel. Channel is a Flume terminology. Flume channel, basically channel carries data from source to sink, and using channels you can connect various kinds of things. Okay, so you have various kinds of sources and various kinds of sinks, and you can connect them together, right? Here the sink, this sink is specifically for HDFS, which is pushing data to HDFS. If there could be a H-based sink, there could be an Hive sink, there could be any other kind of sink. Similarly, source could be various kinds of sources such as syslogd. There could be another source called analytics data, and there could be all sorts of sources for you. And then those sources carry connect to the channels and then carry the data till the sink, right? So just like electrical network, you can build these networks and then use it. All right. So sources can be of various forms, as I was explaining. Tail is one example. So if you have not created any new sources, or if you don't wish to do it and you just want to let the system go the way it was going earlier, and all you want is to take that log being generated and push it to Flume, in those cases, tail minus f is the command which you should be using, and there is a source called tail. It will keep on following your Apache logs and keep on moving it to Flume in the real time. All right. Similarly, syslog is there, which can continuously, this particular source called syslog will keep on moving your data from these nodes to the data to the channel. Now, Flume nodes can be arranged in arbitrary topologies. Typically, there is a node running on each source machine. Okay, and with tiers of aggregating nodes, the data flows through on its way to HDFS. So if there are multiple channels, it will flow through the channels and they'll reach to the sink, and sink will push it to HDFS. Now, while you configure Flume, you could have a delivery reliability, as in best effort delivery. Best effort delivery means it won't tolerate any node failures. Okay. And also in this, there is an important aspect to remember about Flume is that in case, in case sync is not able to read at a very fast pace from channel, the channel size will keep on increasing till till the point it can. Okay, up to a certain limit. And here, so there are two modes it can, the whole Flume can work either in the best effort delivery. It won't tolerate any of the load failures. End to end is which will guarantees the delivery even if there is a node failure. So depending on your use case, in case you are interested in very high availability, okay, then you would probably prefer the first one, basically immediate. If you want it to be immediate and really fast, and in if in your case failure of data is okay, one or two packets drop is okay because you have redundancy of the data, but and so in those cases you will like to have best effort delivery, while in case your data is critical, you want it to be delivered even if delayed, then you go for end-to-end deliveries. That is a Flume way of configuring. Okay, so that is pretty much for Flume. We have not prepared much of an example for Flume. Okay, so as a note, I'm taking it for myself that Flume will set up and then try it out. All right. So Flume, yeah, example is not available right now. We'll take care of that example in future. All right. So now let's talk about Uzi. Uzi is a just like your Ant, Apache Ant. Are you familiar with Apache Ant or Makefile system or Maven? No? Okay. So let me just give you a little heads up that will make you uh, more comfortable. Okay. So yeah. All right. So when you are building a large set of products, so large set of products as in you have say deploy, you want to deploy, right? So you would like to have a command called deploy which will deploy the things. And what does deploy will do? Deploy will say prepare directories and compile code, and then run the test cases, and then prepare documentation, right? And after that it will upload, okay, it will uh, prepare jar and upload to the server. Say these are the steps, right? Now sometimes you might just want to compile the code, right? And compile might further depend on things like prepare directories. Okay, compile might depend on prepare directories. Okay, so deploy depends upon compile code, and compile code depends on preparing directories, right? And and therefore here, and run test case, if you see, run test case also internally will depend only, will make sense only if the code is compiled, right? So run test case itself will depend on compile code, right? So every time you run test cases internally, it will compile the code, right? While prepare documentation only will depend upon preparing directories, right? So basically, such kind of model where we say A depends on B, B depends on C, C depends on E, and so on, right? So that kind of graph is known as directed acyclic graph. Okay, so when you do all of this, and then you could have something called inside test cases, you could have something called email email to email to QA team, right? And you could even have something like delete a particular file delete a file, etc. And basically you could do lots of things inside ant. The ant's only property is that you define all of these tasks in a manner such that when one of these is executed, say if you run only test case, then only these parts will run, and when it starts running compile code, it will also run this part, right? It will prepare the directories and so on. It's like, if I say to you that get ready, if I say to you that get ready for conference, right? Get ready for conference. Now, getting ready means wearing a suit if you are going to conference. Okay, it's like this. So first, for getting ready, you need to wear formals, and then second is that uh, wear formals and put on suit, put on tie, and then put on suit, right? Now, wearing formals itself is a multi-step process. Wearing formals means you first put on put on say shirt and trousers, but and shoes, right? But in interestingly, shoes cannot be should not be worn before the trousers, and so on. So there's a dependency of each of these tasks. Okay, so you define this dependency, who depends on what, and whenever we have to do any of the things, say in case you have to just wear the formals, you just execute only these parts, right? So this is called directed acyclic graph of the jobs. Okay? And this gives you, in case of ant as we described earlier, this gives you really powerful way of building your product. You can say just run the test cases, you can just say compile my code, you can just say prepare the documentation, or you can say deploy. Okay, so it gives you an enormous amount of flexibility of running your tasks. Okay, so you define each individual task, then build a dependency amongst these tasks, and so on. Okay, so exactly the way Ant used to work, where it used to execute tasks here and there for based on their order of precedence. The Uzi is also modeled exactly in the same manner. The only added step in Uzi is that it has a scheduler also. Rather than you always running the command, you can kick in your using a Uzi workflow using a uh, time that execute it on this schedule. Okay, so that is the important part. And the scheduler which runs on the background is called coordinator. Okay, coordinator jobs are recurring jobs on Uzi workflow, and these jobs are basically run based on time and data availability. Remember the two part, data availability and time. Okay, and this is Uzi is basically heavily integrated into Hadoop stack to an extent that you can call a HDFS command from Uzi. Uzi is a scalable and reliable extensible system. In that, everybody can define their own tasks. Just an ugly way of presentation. Uh, so this, I'll just take you through this. So this is the standard way of defining a workflow in Uzi. So you have got a workflow app name, this, and there is a word count action, right? So here it says start in an action, which is the entry point in the game. start is an action which is an entry point in the game. It says my starting pointed word count, which means this one. This is the action which is your starting point. All right. Now, what does this do? First action, if as part of this first action is map reduce. Okay. In case map reduce succeeds, then go to end, right? In case it gives error, then also go to the end. Okay. In case this whole process is killed, is killed, then you display this message called something went wrong. All right. So and this is how you can extract the error message from it. Okay. Now here you go. So under the map reduce, so this except for map reduce, everything is clear, right? So you start with workflow app. Name of the workflow app is this one, and XML namespace is this one. You start at word count, this entry point. Now under this we have defined map reduce. If you see, so for each of the tasks we can say that on success do this, on failure do this. All right, that is the workflow part. Now here you have got job tracker. You can just write a variable which will display the actual job tracker's value. Similar is the name node. You can display the actual name node's value. And here there is a configuration, right? Which says that my class for MapReduce is this class called org.myorganization.wordCount.map, and my reducer class is this class, which is something. Now once you're done with that, so what we are doing here is instead of stitching using a configuration object, you are basically using MapReduce config to do your job. All right. Here, this the Uzi will take care of loading this configuration and executing your mappers and reducers. Right? Is it visible to you on my screen? I'm trying to show you the configuration. How does it look? So this is a typical way of defining a MapReduce one. All right. Now the question comes in that how do I handle such kind of thing? Okay, let me just see. Now here I go to my Hadoop 1.8000. All right, so we have got here, you can see the job designer. Under job designer, you can create. Here there are no jobs available, or you can go to Uzi dashboard. Uzi dashboard shows that there are something which is there. All right, and you can say here. So this Uzi has got a nice interface. It shows you what are the things running. These are the ones which are suspended quite long ago. So we can basically kill all of those. So it is on 21st August. Yes, I want to kill it. Okay, now we have got all of these things to kill. That's okay. Now these are alright. So something is running over there. Some of the students have scheduled it, which are no longer valid long ago. And coordinators are there. All right, so let's just create a workflow. This is our workflow dashboard. And how do you, okay. This is where you can actually create your own workflow. I'll show you. So my test workflow, okay. So you can create a text workflow. So this is an empty slate right now, right? If you want to say that this is my starting point, and then you want to say map reduce, right? You want to run a map reduce, and then say this is my first pass, okay, first, prep data, right? And then you say this is my, not this, all I want is my users. No, here ascii is there. Under ascii, oh, there is no such file. And data, not really. Okay, okay, okay. I don't have a jar file right now, but we can upload a file. We can upload a file. Anyway, so the idea was showing you that you can schedule, add your elements like map reduce, streaming. Streaming is nice because you can run any commands. I'm coming in a minute, okay? Hi Pranav, are you there? So you can actually schedule all of these in this manner. Good, good. So basically, whenever you have to do a lot of jobs in, say, you are importing data first, and then you are running a scoop command. We just described the way we can define what do we want to do with the scoop. Okay, so scoop command, and then say import some data, and here we can write the full scoop command. Either put it here, or split it by spaces, right? So you can put the whole command like that, okay? And that would be good enough, right? So a scoop command, or maybe you want to do a hive command, okay? So that also you can, if you see the hive command, you can write your, basically you can upload your hive script, and then it will run. So all of these things, what we had been doing from command line or manual from the UI, most of these things can be scheduled or can be ordered in a manner. And similarly, we have got even email, right? That once something finishes, send me an email, and then this file system is there in case you want to get the list from, you know, create a directory. What do you want to do? If you want to manipulate HDFS, what is it that you want to do? Whether you want to delete a file, create a directory, move a file, all of this can be programmed from this UI. Okay? All of this can be programmed using this UI. You should try it out, planning something. whatever you had been doing from command line, you can do it from here. Okay. All right. So this is about the Uzi. And yeah, so I actually need to basically prepare the map reduce thing. Right now, I forgot where I've kept my map reducing. And do you want to delete? Yes. So let's just do it instead of delaying it. Instead of delaying it, let's just do it. All right. Now, if you let's just go through our files first. Hadoop one, and if you remember our first session, let's just open up our first session or second session. Or was it third session? I think it was third session. Okay. Let's just show you the pig and hive first. What is going on? Okay. Let's just show you pig and hive makes sense. Good. Now here, let's just take a pig case, and under pig, so pig and so we can say ls and cd as giri. So I was just thinking that I think what we can do is, okay, let's just do a very simple thing. My ratings equals load ratings.csv using using pig catalog could not resolve. What was that? If you remember, using pig catalog or using, let me just pick up something from session number 5. Alright, so we were doing a simple example. Okay, NYSE daily. So NYSE daily, where does it exist? I think it is under data, right? Perfect. So what we can do over here, we'll have to provide an absolute location. Perfect. We say slash user slash NYSE daily instead of saying simply this. Similarly, we go with this, and then we say JND and then store J and D to my out. All right. So this should work fairly good. What is it? Hmm. So we have, this is fine. So we loaded daily into this, and we loaded this, and then we joined it. Good. And all we want to do is store. What is wrong with this? So we have, okay, right? Now let's just write it as a script. Okay. So this is our pig script, and script name will have to upload our script here. So this is our pig script. So I say my pig script dot pig. It's not necessary to have pig as a name, and I say that my file is uploaded. All right. Thank you. Yeah, the semicolon was missing. You're right. But there were other problems also. I was not putting into in the command. Okay, so simple pig, and here you go. Now we can say add, delete, add, make directory. No, we don't need to do that. This is good enough. Job properties, we don't need to define a file path, and that's all. Perfect. Okay. Now, what did it say? Fail to produce result in out. What did it say? Why did it fail? Okay, what is it saying? Yes. Okay. The job has failed, and why did it fail? Let's see the job. This has failed. Parent path is not a directory. You're right. You're right. So basically, we have to put our data over here like this. Now let's just edit workflow, and we can say we can edit it. All right, and okay. Now let's start the workflow. Okay, so for time being, let me just replace it. All right, no worries. Now that's all. Workflow saved. Close it. Now, if you click on my workflows, do you see this particular one? Why does it say XML schema error? Value simple is not. Uh, uh, uh. It want that name to be saved, and then I can say submit from here itself. So at the end of it, we should have a file there, right? Right now, we don't have a file here. We don't have an out file over here. It should create an out file over here. All right, let it keep running. All right, so as well as you can see over here, this is the workflow app. This is the workflow which is generated automatically. So this is where we uploaded our file, the script file, and then we are running it. All right. In case it gets killed, this is what the error message is printed and it's finished. And this is pig command, which runs, on the name node, whatever, and that's all, right? So in case you want, you can keep looking at the XML, and also you can stitch it by yourself once you have. Okay, so you can prepare a whole XML and then do the job. And while loading in workflows, if you uh, 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 so let's just go to our Uzi dashboard. The maximum retries are done. Don't tell me our. Why did it go down? Let it go. Hadoop 2.no big data max retries exceeded with URL this caused by socket error. Strange. And yeah. Now it should work, right? So it creates a directory for you, and this is where your workflow is located, right? Uh, so in case you go into the directory, you can see that part. And okay, now, so yeah, so let it run. It will take a bit of time. This is where it is going to do some things. I think let it finish. All right, let's see what's going on with the logs and test workflow external ID logs. All right. So after some time it will finish, and it has not finished. I think it is killed. Okay, this is done. This is running. All I want to see is log. Is running back. It's not. All right. So you can have I mean, basically you can execute your jobs in the similar fashion, the way we have run just now. So in case you want to do it every nightly from now and then, what you can do is you can define a coordinator. Okay. You can go to the coordinators tab, main tab here, and you can create a coordinator. All right. You can define something like, let's say, my coordinator, and some description you can put, and you can put in this, the one which we just created, and then you can define the frequency. All right, this is the beautiful part, because now you no longer have to define the cron expression. Do you know cron expressions? So you can beautifully create these calendar events, and then okay. So basically, cron expressions were a way of defining a schedule. It's sort of a regular expression, and in which you can, it's sort of like, how should I? Okay, I mean, that is the standard way of defining. Internally, whenever we define a frequency or anything, under the hood, it creates a cron expression. And you can define this and then say save coordinator, save the coordinator. If you define the inputs, then it will basically be watching that input. What is UC for? Scheduler. Okay. 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 Great. So it is fine. It is running now. And I just hope that it finishes someday. Let it run. Then we continue our discussion. So in this manner, you can start with the workflow. All right. You can start with the workflow. So as I described, a directed cyclic graph is something of this sort. Okay, it says that fifth job depends on 11, 11th job depends on ninth, ninth job does not depend on anybody, and 11th job also depend on 10. So whenever we want to execute 11, it will first execute 10, then 9, or 9 and then 10, and then 11. Similarly, if you want to execute 8, it will first execute 9 and then execute 8. But if we are executing something like 2, it won't execute anything other than 2, because 2 does not depend on anybody. Why 5 is the biggest one. So 5 will first depend on 11. 11 will first execute 2, and then 9, then 10, and then itself, and then fifth. So this is how a general graph of a directed acyclic graph actually works. In the similar manner, you can, the whole UZI workflow is basically a directed acyclic graph. And an interesting part of this one is there cannot be a cyclic dependency. It cannot be that 5 depends on 11, 11 depends on 10, and 10 depends on 5 back. If it is so, then you cannot use that. That's not directly a cyclic graph, and no such execution can happen in a cyclic manner. It will keep running forever. All right. So this is I mean, more or less about our UZI. So UZI basically covers, I mean, all of the commands we have used so far basically can be run through UZI. All right. Now, Here I wanted to demonstrate to you this part. Okay. So so that's pretty much with respect to Uzi. You can have more documentation over there. So we talked about Scoop, we talked about Flume, we talked about Uzi. Today we are going to talk about Mahat also. Should we continue or is it enough for today? Pranav? Okay, okay. Then have a good night and we'll continue our discussion. If other people are available tomorrow, then we'll have a discussion tomorrow. Otherwise, we'll have a discussion on next Saturday, Sunday. All right. Thank you, Pranav, and see you next next weekend. All right. Bye bye. Have a great day.